Good morning, afternoon, or evening to everybody. Welcome to the third talk in the workflow session for the Mile High Video 2020 workshop. Today we are going to discuss something that was a 2-year effort to document common industry video workflow combinations. This effort involved a worldwide set of people representing all aspects of the workflow chain, from content providers, broadcasters, service distributors, finally technical video product developers. The result of this is a joint ITU ISO document, now in its second edition, that provides a great resource for dealing with all the new and different content workflows that are just starting to appear. To give some production and distribution perspectives today, this talk is actually a joint presentation from Chris Seeger from NBCU, who deals a lot with some of the content production factors, and myself from Comcast, who deals with the service distribution factors. Now, a while back, but really not that far back, times were simpler. Basically, delivery to TVs were modeled after CRT displays, which had a color space of 601 or 709 and addressed the brightness of pictures to about 100 nits. And in essence on this, the conversions were fairly simple. You might do a resolution conversion going from SD to HD. You might do color space conversions from doing 601 and to 709. You could do some aspect ratio conversions from 4:3 to 16:9. And this was all usually in the 420 color subsampling area with 8-bit YUV video. The pictures had to be delivered to a restricted display quality, which was actually more forgiving on types of conversions and any mismatches that may occur. Today, this picture has changed. Actually, what's happening is the pixels are changing. There are now more pixels, so we're talking about something with higher resolution in terms of 4K, and 8K is already starting to be mentioned out there. There are faster pixels, which in this case means higher frame rate pixels. So instead of just having just 25 or 30 frames per second, we're now talking about 60 frames per second or even 120 frames per second. And then lastly, they're better pixels. These pixels can have a better dynamic range, which basically means you have brighter and darker pixels. And it could also increase your color gamut to have more colorful pixels. And what this indicates is that the video signals now contain more information that can be delivered to displays, and today's displays are actually more capable of showing these new pixels. For instance, what this affects is things like preserving skin tones as you're going through conversions in the process. And preserving skin tones is critical for quality purposes because it's usually easier to detect, and it's often a nonlinear conversion process. So if we just had to deal with these types of conversions and there were just very few workflows, it would be easier to manually tweak this. But looking at what's happening in the industry today is there's by far more volume of content that's increasing, and it's over a diversified set of resources. So just to give an example of this, and this is from FX Network Research, the amount of scripted workflows that have been increasing over the years has tremendously increased from something of about 266 episodic, scripted, and reality types of content into 2018 to 495, and this has increased all the way since 2020. And this is not just its current volume, but if you start adding stuff that has not been considered, we're talking about live events. That's going to increase because you have news and sports, you have localized events that will have a wider distribution. And lastly, there'll be actually more adoption of user-generated content because there's a lot more video equipment available, and it's really good, and it's already becoming inexpensive. So we do expect a lot of user-generated content out there. So on top of this, we have better signals, we have more content, but then also there's more display devices. So now we're not just talking about TVs, we're talking about mobile phones, we're talking about tablets, we're talking about TVs that are OLEDs or QLEDs, and then additionally laptops and projectors. There are more display formats with SD, HD, HDR, 4K, 10-bit, 8-bit, 422, 420s, and more distribution pathways to the display, broadcaster cable, IPTV, Wi-Fi. And then lastly, there is an increase in personalization of the video signal. And this may come into its effects through integration and compositing somewhere down in the workflow or at the receiving device. In essence, what this happens is this expands what content workflows need to handle and open up these workflows to an expanded dimension of conversion factors. And this is critically important because now we have displays that can show expanded quality on this. For the next set of slides, Chris will explain in detail some of the importance of maintaining quality as we go through these conversion processes in each of the workflow stages.
Thanks, Yasser, and hello, everyone. Whether you are using baseband via SDI or 2110 for a live linear production or are file-based in post-production, the compositing of multiple sources of video requires signal normalization. Normalization takes sources from multiple formats and converts them to a single format so they can be mixed together, superimposed in the case of graphics, or simply switched from one picture to another. In this slide, you see sources that are in standard dynamic range, HLG HDR format, and PQ HDR format. The blue format represents the normalized working space of PQ BT2100. Any source that is different from the working space is normalized to the single format. After the compositing is completed, secondary conversions are possible. This methodology, associated with proper signaling of the video format during production, transmission, and final viewing on the consumer display, is what makes UHD with high dynamic range and wide color gamut possible. Truth be told, signaling of transfer functions and color spaces has been around for a very long time. It's just that the differences between the SDR 601 color space and SDR 709 color space was small enough that if a mismatch occurred, many people just didn't notice. That isn't quite the case for HDR and wide color gamut. So let's take a look at what we call a single stream UHD HDR production and distribution chain. If you look at this drawing, you can see that as we move through a UHD production and distribution workflow, we can capture in a higher bit depth different color representations, transfer functions, color spaces, or chroma subsampling methods. By the time we get to distribution, we will have gone through a number of very necessary conversions. Without proper signaling, this becomes a very manual and trouble-prone process. Signaling in a diverse ecosystem therefore becomes essential. The ISO document consolidates approximately 47 different standards references into a sort of pocket reference that has as its single mission to provide a quick reference, but also to point back to the comprehensive standards document itself. Now let's take a simplified look at another example of production and distribution in a baseband format. This slide gives you a better window into what might happen in a production through transmission chain. Multiple sources are arriving on the left-hand side and are represented by the different color-coded video formats. The SDR sources all need to identify themselves correctly so that the correct conversions are used and video is normalized into a single HDR format and color space, where it is then added to the central router. As video leaves the production router, the native HDR sources are identified through their signaling and converted to SDR, which will then have their signaling replaced so that the video is correctly identified on the SDR channel. Towards the bottom of the drawing, in green, as HDR video arrives in transmission, HLG video gets converted to PQ for a consistent consumer experience at home. The signaling is again replaced so that the video format is identified correctly to the encoders. As the signal gets converted for final delivery, HEVC identifies the video format through CICP parameters, VUI, and SEI messages. More details for this process are in the ISO document along with the full standards. Another look with different detail is shown on this slide and is available for reference in the downloadable deck. Okay, so let's take a look at the variety of content that can play into the workflow and what happens if there is a content mismatch. Since you are probably not using an HDR display, this example is meant as a simulation. If a video with high dynamic range and wide color gamut is viewed on standard dynamic range and standard color gamut displays, it is extremely apparent that something doesn't look right. If any of you have viewed a camera log video on a regular display, this should look familiar. But with correct signaling, the correct conversion and viewing choices can be automated or at the very least made more consistent because the operator will know exactly what format the video is. LUT conversions are typically used to convert from one video format to another. Ultimately, they will be able to make automated choices if correct signaling is included and once the transform headers are more standardized. Right now, HDR to SDR down conversion LUT design is typically based on subjective decisions, but NBCU has developed some tools which allow us to make more objective decisions. Unfortunately, there is still one parameter that has not been standardized in LUT conversion, and that is the video range parameter. DaVinci Resolve has recently added this parameter to their LUT specification, and I hope others will follow. The other parameters that need to be set are fairly standard and therefore can be automated when the proper signaling is included. And now let's get back to Yasser to sum it all up.
Thank you, Chris. So, with greater diversity of content and increased volume, conversion processes become very important between the workflow stages, and at this scale, it needs to be automated. This is done through signaling of what type of content it is and metadata to carry out this information. Additionally, if we do have the signaling and metadata in place, it also allows for the advantage of incorporating independently developed tools into the workflow, which is always good because it increases the robustness of the workflow process. This talk comes around full circle again to the ITU ISO technical record. This document spans different domains, and note that there is no other signal document out there that has all this collected information in one place. This is over 45 references. It is a great resource for those converting content and for those developing content workflows. Again, it already has lots of experts from the different domains of content and provides a place to add additional information in the future. The advantage of this document is that it provides a more restricted set of the video property combinations, and this set is those used by the industry, so it reduces down to about 10 to 12 combinations. Additionally, it provides a common set of grading environments used in the industry as well. This will be even more useful as user-generated content becomes more popular and is added to the mix, because this will allow third-party tools to integrate smoothly into the content workflow. Now, the next set of slides describes some of the tables within the document, but it won't describe everything. So really, just download a copy of the specification and read the details for yourself. Now, in this first set of tables, the table on the left basically describes the two video combinations that are used in the industry. This is basically HDR10 as well as HLG. And for the video properties, you see that there's color properties of color primaries, transfer characteristics, color representations. Additionally, it shows full narrow range as well as chroma location types. Now, these property combinations are then described in a coded bit stream using the CICP parameter properties, as well as how this information is described maybe more in production with the SMPTE MXF properties. The table on the right is sort of a summary table on those 10 to 12 industry video property workflows. So it gives an indication of what all the parameters are. but then also it identifies a tag to uniquely identify this, and this is useful to put that tag into the metadata workflows. Another table in the document is this baseband workflows, and in which case shows the different types of baseband specifications out there. So ST259M is an SDI interface, but then it goes all the way up to quad link 12G, single or multi-link 10G as well. And this document will indicate how you could incorporate this to infrastructure plant designs to support those bigger, faster, better pixels. One of the last tables I wanted to show you was the master and display color volume table, in which indicates the grading environment or the type of monitor that is used for grading of the content. So this table itself shows the HDR grading environments, and the ones that are used in industry today is P3D65 at 1000 nits, P3D65 at 4000 nits, and for projectors, BT2100 at 108 nits. This is important because it affects how you convert the content from one production or distribution stage to the next one. So that's the end of this presentation. Both Chris and I would like to thank you for the opportunity to present this important topic. We believe this will be increasingly important as we automate content workflows while preserving video quality. Doing this and incorporating this information will help move things at a faster pace from production to finally delivery of the content to the display. Thank you for your time, and if you have further questions, please reach out to myself or Chris.